So here's the study of professional football players in the United States. That's the population. So it's all pro football players in the U.S. That's what we're intending to study. Now that's too many to study, so there's been a sample selected. The sample is the set of players selected from each team. Now, what variables are measured? So remember, variables are characteristics that we're studying. And notice that what was measured was eye color, jersey number. So those are variables. Eye color, jersey number, weight, and number of children. So those are, I guess that's it. Yeah, just those 4 variables. Now, for each of these variables, let's ask ourselves, is it qualitative or quantitative? Eye color is pretty clearly qualitative. It's not a number at all. Let me skip jersey number for a minute and go down to weight. Weight is quantitative. It's a number. And notice that it could be meaningfully added or subtracted or averaged. So you could say, you know, this team total weight is greater than that team total weight. You could add up the weights and perhaps look at the weight of total teams. Similarly, number of children, that's quantitative. It's clearly a number, and it could be meaningfully added or subtracted. So you could add up the number of children for the players on one team and say, okay, this team needs this size daycare facility, for example, because this is how many children they have. Let's go back now to jersey number. Jersey number, of course, is a number, but would it make sense to add up the jersey numbers of members of a team and say, well, here's the jersey number total for this team, or here's the average jersey number for the team? It kind of doesn't make sense. The jersey number is really functioning. It's a lot like having the person's name on their t-shirt, right? So even though it's a number, this is one of those deceptive ones that are a number, but they're really qualitative. So I guess if you compare that to like the zip code example, those are zip codes and jersey numbers. They're really sort of identifier numbers, and it doesn't make sense to do arithmetic with them. Okay, now the two variables that we decided were quantitative, weight and children, are these continuous or discrete? Weight is, hopefully you said it was continuous, right? Because there's no gaps between possible weights. You know, the players, it's not like you could only have weight 200 pounds, 201 pounds. No, you could have any weight in between those two numbers as well. You can have fractional weights. Children, however, okay, you can't have 1.5 children. There's a gap between the number 1 of children that you can have, or the 2 children that you can have, or the 3 children that you can have. So that's a discrete variable. Okay, so let's see. So the weights of it, says we recorded the weights of the players that we sampled. So the sample of players we took recorded their weights. Suppose we took the average of their weights. Would that be a parameter or a statistic? Well, we recorded weights of players in the sample, so the average of these weights is referring to the sample. So that's a statistic. On the other hand, if we knew the average weight of all of the professional football players in the United States, remember, the population is all the professional football players in the United States, so the average now is a number describing the population, so that is a parameter. Right, so sample, statistic, population, parameter. Last question was, a player's eye color is recorded as hazel. Is eye color the variable or the data, and is hazel the variable or the data? Remember, a variable is the characteristic that you're studying or measuring, and eye color is a characteristic, so that's the variable. Data is an observed value of the variable, so hazel is one of the possible values of the variable eye color. So it's one of the specific values of the variable that you might write down. So that is data. That's a data value.